Welcome to month 6 of the Data Engineer track, the final session in the BISTEC Hearts Academy journey. This is the Capstone month. Everything you have learned across the past 5 months comes together today. Foundations, data modeling, pipeline development, data quality, and performance optimization. Today you'll design a complete production-grade data platform from scratch, build the orchestration layer, define the governance model, and present your work. By the end of this session, you will have graduated from the Data Engineer track. Here is the shape of today. 4 hours structured around 3 phases. The first hour is lecture-based. We will cover platform design patterns, orchestration with Airflow, architecture trade-offs, and CI/CD for data pipelines. This is the last new technical content in the track. Hours 2 and 3 are the capstone. We will design a data platform for Retail Co., a realistic mid-size retailer with real-world constraints and requirements. This is hands-on, practical work. Hour 4 is presentations and graduation. You will present your platform design, defend your architectural decisions, and then we celebrate completing the track. The keyword today is end-to-end, not one layer, not one tool, the entire data platform, from source to serving. There are 5 objectives for today. First, reference architecture design. You will draw a complete platform architecture using Azure services and the Medallion pattern. Not a theoretical diagram, but one that could be handed to a team and implemented. Second, orchestration mastery. You have used Airflow in previous months. Today you will build a master DAG that orchestrates an entire platform with Spark operators, quality gates, and CI/CD integration. Third, architecture trade-offs. Data mesh, Lakehouse, traditional data warehouse. You will compare these for a real scenario and justify your choice with specific reasoning. Fourth, capstone delivery. You will design, document, and present a complete data platform. This is the deliverable that represents 6 months of learning. And fifth, career readiness. After today, where do you go next? We will explore growth paths and certifications in data engineering. Let us look at what a modern data platform actually looks like end-to-end on Azure. Start at the top, data sources. In a real company, you are dealing with transactional databases like Azure Skill or Cosmos DB, event streams from Event Hubs or IoT Hub, files landing in blob storage, and SaaS systems like Dynamics 365 or Salesforce. Each source type has different characteristics: volume, velocity, format, and reliability. The ingestion layer handles getting that data into the platform. Azure Data Factory is the workhorse for batch ingestion. Spark Structured Streaming handles real-time workloads. For change data capture, tools like Debezium or ADF change tracking let you capture only what changed, which is critical for efficiency at scale. The storage and processing layer is where the Medallion architecture lives. Bronze is raw data on ADLS 10.2 in Delta Lake format, exactly as it came from the source. Silver is the cleansed, validated, conformed layer where real data engineering happens. Gold is the business level aggregates and star schemas optimized for consumption. Finally, the serving layer, Synapse Serverless and Power BI for analytics and dashboards. Azure ML and MLflow for machine learning workloads. APIs and Cosmos DB for operational use cases where applications need to query data directly. This reference architecture is what your capstone design should follow. You have seen the Medallion architecture in earlier months, but today we need the complete picture because you are designing all 3 layers for the capstone. Bronze is the raw zone. Data lands here exactly as it came from the source system. It is append-only, schema on read, and preserves the full history and lineage. The critical principle: you never mutate bronze. If something goes wrong downstream, you can always reprocess from bronze as your source of truth. On Azure, this means Delta Lake tables on ADLS Gen 2. Silver is where the core data engineering happens. Schema enforcement, null handling, deduplication, conformed keys, and slowly changing dimension tracking. Great expectations quality gates sit between bronze and silver. If data fails validation, it does not progress to the next layer. Gold is where the business lives. Aggregated KPIs, star schemas optimized for Power BI, and feature tables for machine learning models. Gold is optimized for consumption, not transformation. 4 principles underpin this architecture. Immutability. Bronze is never modified. Incremental processing. Each layer only processes changed data using delta merge and watermarks. Quality gates. Automated checks between layers prevent bad data from propagating. And governance. Unity Catalog or Azure Purview provides lineage tracking, access control, and compliance. You have written Airflow DAGs before? Today we are talking about the master DAG pattern, a single DAG that orchestrates your entire data platform. 4 key patterns on this slide. First, Spark Submit Operator. This is how you submit PySpark jobs to Databricks or HDI Insight from Airflow. You pass parameters, Airflow tracks the job status, and retries are handled automatically. Second, Great Expectations in DAGs. The Great Expectations operator runs validation checkpoints between pipeline steps. If data fails validation, the DAG fails fast, triggers alerts, and blocks downstream tasks from running. Third, Sensor Patterns. External Task Sensor creates dependencies between DAGs. Blob Sensor detects when new files land in Azure storage. These are essential for building event-driven orchestration patterns. 4. Azure Integration. The Azure Data Factory Run Pipeline Operator lets you orchestrate ADF pipelines from within Airflow, which is valuable in hybrid scenarios where batch ingestion runs in ADF and transformation runs in Spark. The code sample shows the master DAG skeleton. Ingest to bronze, validate with Great Expectations, transform to silver, then aggregate to gold. Each step uses Spark Submit Operator to submit jobs to Databricks. This is the pattern your Capstone DAG should follow. One important tip. Use Airflow task groups to organize your DAG visually into bronze, silver, and gold stages. And always set retries with exponential backoff for Azure service calls, since transient failures are common in cloud environments. This is a comparison you will need to make in the Capstone. Which architecture pattern is right for retail core? 3 approaches compared across 6 dimensions. In a traditional data warehouse, the central data team owns everything. Governance is top-down with strict schemas. Storage is schema on write, typically Synapse dedicated pools. This works well for small teams with well-defined analytical queries. In a Lakehouse, you still have a central team, but with a shared flexible platform. Governance uses Unity Catalog or Purview. Storage is Delta Lake on ADLS Gen 2. This architecture supports both analytics and machine learning workloads on a single platform. Data mesh takes a fundamentally different approach. Domain teams own their own data products. Governance is federated, meaning each domain follows shared computational policies. Storage can be polyglot, with each domain choosing what works best. This shines in large organizations with 5 or more data domains. For retail core, the recommendation is to start with the Lakehouse architecture. It provides the flexibility of a data lake with the reliability of a warehouse. You can adopt mesh principles like domain ownership and data as product thinking incrementally as the organization matures. Avoid attempting a big bang mesh transformation. That is an organizational change, not just a technical one, and it requires a level of maturity that most mid-sized companies have not yet achieved. CD for data pipelines follows the same principles as application CI/CD with some data-specific considerations. 5 stages in the pipeline. At the commit stage, you link PySpark code, run unit tests with PyTest, and validate schemas. During the build stage, you package Spark jars or Python wheels, build Docker images, and compile DAG definitions. The test stage runs integration tests against sample data, executes Great Expectations checkpoint validation, and performs DAG import tests to verify Airflow can pass your definitions. Deploy to staging means deploying to a development Databricks workspace, running the full pipeline on a data subset, and validating output schemas match expectations. Finally, deploying to production involves a manual approval gate, a blue-green DAG swap to minimize downtime, and active monitoring of the first production run. The code sample shows an Azure Pipelines YAML configuration. Notice the test stage runs PyTest, validates DAG imports, and executes Great Expectations checkpoints. The production deployment only proceeds if all tests pass. 5 best practices to follow. Separate your DAG code from your transformation code in your repositories. Use Azure DevOps or GitHub Actions for pipeline automation. Test with synthetic data that mirrors your production schemas. Use Delta Lake time, travel for version control and rollback capability. And always gate production deployments on data quality checks passing. This is your Capstone challenge. Everything from the first hour of today and everything from the previous 5 months comes together right here. Retailco is a mid-sized retailer with 200 stores, an e-commerce site, and a loyalty program. They need a unified data platform to power real-time inventory visibility, personalized customer recommendations, and executive dashboards. Their current state is what you will find at many companies. Siloed SQL Server databases, manual CSV exports, and no automated data quality checks. 5 data sources to handle. POS transactions generating 500,000 records per day. E-commerce clickstream events and inventory management system. CRM data in Dynamics 365. And supplier EDI feeds. 5 business requirements to meet. Real-time inventory visibility across all 200 stores. A customer 360 view for personalization. Executive KPI dashboards. Refreshed daily. ML-powered demand forecasting, and full GDPR and PI compliance. 3 critical constraints. Azure Cloud is mandatory because of an existing enterprise agreement. The team is small, just 4 data engineers and 1 analyst. The budget is moderate, which rules out expensive options like Synapse dedicated pools. You have 2 hours to design and build your solution. Then you present and defend it in the final hour. Part 1 is architecture design. In 45 minutes, you will produce a complete architecture diagram from sources to serving. 5 things your architecture must include. The end-to-end data flow drawn out clearly, specific Azure services chosen for each layer with justifications for those choices, Medallion zones with specific schemas for Retailco data, a clear designation of batch versus streaming for each data source, and networking and security boundaries. For hints on Part 1, ADLS Gen 2 plus Databricks should be the platform backbone. Event Hubs handles the POS real-time transaction stream. Azure Data Factory handles batch sources like CRM and supplier feeds. Part 2 is integration and orchestration. Another 45 minutes. Your deliverable is a master Airflow DAG, plus at least 1 working PySpark transformation. 5 requirements for Part 2. Design the master DAG for the full Retailco pipeline. Include Spark Submit operator for each transformation stage. Add great expectations checkpoints between Medallion layers, define error handling and alerting via Slack or email, and write at least 1 PySpark silver layer transformation with proper schema handling. For hints, use Airflow task groups to visually organize bronze, silver, and gold stages. Parameterize dates so the DAG supports backfill operations. Add SLA alerts on critical data paths. Part 3 is governance and operations. In 20 minutes, produce a governance plan that covers 6 areas: data classification tiers for public, internal, and PI data, access control using RBAC via Azure Active Directory, data quality monitoring with great expectations dashboards and automated alerts, a PI masking strategy to ensure GDPR compliance, lineage tracking via Azure Purview, and an incident response runbook that documents what happens when a pipeline fails. Part 4 is presentation preparation. In 10 minutes, structure your 8-minute presentation to cover the problem statement, your architecture walkthrough, a DAG demonstration or code walkthrough, your governance model, and a proposed delivery timeline. Be prepared to defend your trade-off decisions. Evaluators will challenge you on cost, scalability, and why you chose one Azure service over another. The evaluation rubric is weighted as follows. Architecture design is 30%. Integration and orchestration is 25%. Governance and operations is 20%. The presentation itself is 15%, and code quality accounts for the remaining 10%. You have spent 6 months building skills across the full data engineering spectrum. So where do you go from here? 4 paths to consider. Senior data engineer is the individual contributor track, focused on depth. You own complex pipelines end to end, designed for scale and reliability, and mentor junior engineers. The key skills are Spark, Delta Lake, and performance optimization, all things you have practiced in this track. Data engineering led is the people track focused on breadth. You make platform architecture decisions, build and manage a team, and communicate with business stakeholders. The key skills are architecture, leadership, and strategy. Data architect is the architecture track. Enterprise data modeling, governance frameworks, and cross-team standards. This is where you shape how an entire organization thinks about data. ML or analytics engineer is the specialization track. Feature engineering at scale, MLOps, model serving, and real-time ML pipelines. This sits at the intersection of data engineering and machine learning. All four paths build directly on what you have learned in this track. My advice: build a public portfolio, contribute to open source data tools, write about your platform decisions, and pursue the Azure Data Engineer Associate Certification, DP203. That credential, combined with what you have built here, positions you very well in the market. Let us be clear about what is being submitted and how it is assessed. 5 deliverables. The architecture diagram is worth 30%. This is the most heavily weighted because it demonstrates your ability to think at the platform level. The master Airflow DAG is worth 25%, demonstrating your ability to orchestrate a production pipeline. The governance plan is worth 20%, showing your understanding of operational data engineering. The Capstone presentation is 15%, reflecting your ability to communicate technical decisions clearly. And the PySpark code sample is 10%, at least one silver layer transformation with tests and documentation. Push everything to your GitHub repository. Include a read with setup instructions and your architecture decision record. The submission deadline is 1 week after today's session. Completeness matters more than perfection. A working end-to-end design with clear trade-off justifications will score higher than a perfect architecture diagram with no DAG or governance plan. And that brings us to the end, not just of today's session, but of the entire engineer track. Look at the journey. Month 1, foundations. Month 2, data modeling. Month 3, pipeline development. Month 4, data quality. Month 5, performance optimization. And today, month 6, end-to-end platform. 6 months ago, many of you were writing skill queries and loading CSV files manually. Today, we just designed a production-grade data platform on Azure, complete with orchestration, quality gates, governance, and CI/CD. That is a remarkable transformation. Congratulations, data engineer. You earned this. Keep building. Keep learning. The platform is yours. Thank you for being part of the BISTEC Hearts Academy, and best of luck on the path ahead.